Today, we'll be talking about cancellation tokens. Now, there's a lot of ground to cover, so I'm going to split up this video into various segments. You can skip right ahead to the part that you're interested in. Now, we'll start with a little bit of history to understand why things are the way they are. Then we're going to cover the basics, of course, and then we're going to do a whole section about best practices and potential pitfalls. We're going to wrap up the video by talking about two underused features, which is linking tokens and registering for the cancellation event. Let's go. Okay, so back in the early days of .NET, we used the following mechanism. Now, suppose I have this little method right here, which is just going to print some kind of character, and I'm going to create two threads here. Yes, threads. And we're just going to do the following. So let's do print char, and I'm going to pass along just a dot here. There we go. And then I'll make a second one, t2, and we're going to print out another character, right? Yes, I am using thread.sleep as well. Please don't do that in an actual application. So, since we are using threads, we have to start these manually, and just to make sure that our application doesn't quit before they actually did their work, we're going to also join these. There we go. Okay, let's quickly see if it works. And there we go. We have these two characters and some nice little race conditions there. Great. Okay, that seems to work. Now, how do we cancel things, right? How do we say, oh, you need to stop doing whatever it is that you're doing? Well, the mechanism we use for that is, well, the following. You can go, let's say, after a certain period of time, then we're going to abort thread number one here. So what does abort do? Abort will actually throw an exception on that thread, right? Thread number one, wherever it is in the application. So that means that we have to catch it here in this particular method. So let me just add a try block here, and I'm going to catch the thread abort exception. There we go. All right, so let's try this. We're going to abort, and then after a little while, we go to catch that exception. Let's see if it works. And indeed, after a little while, you can see that the one with the dots is cancelled, while the other one will continue. Okay, great. Now, we're not using this technique anymore today. Why not? Well, there are a couple of problems with this. First of all, this only applies to threads. So these days we would use a task instead of a thread to represent a piece of work. Second of all, you don't know exactly when this exception will be thrown. So it could be at any moment in this code, which makes your cleanup very, very difficult. Now here I don't actually need to clean up something, but what if you are writing to the screen, you're reading a file, and so on, you're talking to the network, whatever is going on, you have to be able to, just drop everything and be able to deal with that situation, which is, well, quite challenging. So we're not going to do that anymore. Another problem is that it also kills this thread. So if you have a look at the thread state at the end, you will see that this is aborted, which renders the thread useless. You cannot use it again. Now imagine doing that with a thread on your thread pool. Also, it is quite expensive to create and destroy threads all the time. So you get my point, right? This is not the best approach ever. So how could we improve this? So first of all, let's try to deal with the fact that we have to, catch this exception anywhere we are. Instead of using this model where one thread just, straight up kills the other thread, maybe we could use a more cooperative model. So what we could do is the following. We can add a little Boolean here that just says, okay, is cancellation requested? And then we're going to just check that Boolean. Now I am going to mark it as a volatile. There we go. This is just a little hint to the compiler that multiple threads might access this value simultaneously. This will tell the compiler that it cannot do certain optimizations, which could lead to reading stale data. It's not a very common keyword these days anymore. Anyway, we have this thing right here, and instead of doing this abort, we are just going to kindly ask, hey, could you consider stopping whatever you're doing? Let's make this static. All right. And then in here, we are just going to check at a place that makes sense, right? If we want to stop. So here you can check this thing. If cancellation is requested, then we can, well, maybe move this line here, right? We do any type of cleanup that might be necessary. And then we are just going to return from this particular method. So we don't even need this try catch block anymore. All right. So this is a cooperative model. Once I ask, could you please stop whatever it is that you're doing? And then here we have full control over what happens when that cancellation is actually a request. Like, do we actually stop? Do we stop right now or a little bit later, and so on? So we have much more control about this particular situation. Also, this is a Boolean that I can now pass to several methods. So right now, this is not just for thread 1. I'm actually going to stop both threads with that same Boolean. If I want to stop them separately, I would just have to create a second Boolean, right? Okay, let's see if that works. And then there we go. We have this nice approach, and notice that my thread is now just stopped and not aborted. And this is what brings us to the modern era, to what we do with cancellation tokens and the cancellation token source. All right, so let me explain that. Okay, so how do cancellation tokens actually work? Well, we need two parts. First of all, we need something known as a cancellation token source. You can think of this thing, the cancellation token source, as a big red button, right? And what we're going to do then is this thing has a token, and we're going to give that token to a certain method, right? Now, that method does a couple of things, and it calls other methods, and we're also going to pass that same cancellation token to various other methods. And this just keeps going and going, so you just keep passing this cancellation token to the very depths of your code. Now, at one point, we might hit cancel, right? So we press the big button, and then all of these start flashing. Basically just kindly asking, like, can you stop, right? And then it's up to the current method to decide what to do with that information. Am I actually going to stop? Will I stop immediately or a little bit later, and so on and so on? Do I need to clean up these things? So each individual part here will have to take care of itself. So it is a cooperative model. So what does that look like in code? So this is a .NET 9 application, and I copied over the code that we had earlier. So first of all, notice that this thing actually no longer exists. It's not just deprecated, it is simply not implemented. It will throw a platform not supported exception, right? So we need to get rid of basically all of this. And right here, let me just use task.delay, to avoid blocking our threads. Much better. And then I have to turn this into an asynchronous method. Great. And this one, let me just put it to any exception. And then let's also change this into a regular task, right? So I'm just going to call the method. I'm not going to await it just yet. I want to do that here at the end using task.when all, and I'm just going to pass T1 and T2 in here. So we just await both so they can still run simultaneously. I guess we could use a task.delay here as well. There we go. And then we actually want to cancel that. So bringing in the cancellation token source. So cancellation token source is just a class that we can use. You give that thing a name. Source, for example, is new cancellation token source. Okay, and this thing contains a cancellation token, right? So let's call this one cancellation token, just to be very clear, source.token. There we go. And then we should pass this cancellation token to these various methods, right? So quite typically, the cancellation token will be the last parameter that you add to a certain method. Let's fix this method. We know what to do, right? We need to listen to that cancellation token at an appropriate place. So quite typically, in a loop, like in the very beginning of loop, is a good location before starting all sorts of work that you might have to undo later on. So right here, I can check, hey, has this cancellation been requested? And then we can do various things. For example, we can do this amazing piece of code and then return. Maybe we can do additional cleanup or whatever, right? Now, this is one approach. Probably you don't want to use this approach. Instead of this, you are going to do the following. You're going to say, okay, cancellation token, throw if cancellation is requested. And this may remind you of the previous model. This will ensure that we actually have an exception, and this will be the operation cancelled exception. Then all of this stuff, we can just move it right back over here, and we can get rid of all of this. So this is the typical pattern, right? So in various locations, you're going to check if cancellation is requested, and if so, we're going to throw this specific exception, immediately leaving whatever it is that we're doing. Now I'm catching the exception right here. You don't have to do that. These exceptions can bubble up the call stack. So now that we have this in place, let's actually cancel this. So the way to cancel this is by talking to that source. You have a couple of methods. You have the cancel method, which is the one I'm using here, but you also very conveniently have this cancel after method, which can take a timeout. There's also a cancel async. I'll talk about that one at the end of the video. So this is the moment where we hit that big red button. Then everywhere where I pass this cancellation token, I can then see that this is now cancelled, and I can decide what I want to do with that information. Okay, let's see if it works. And indeed, you can see that, well, both were actually cancelled. If I don't want to cancel the second one, I need to pass along a different cancellation token. You actually have one called CancellationToken.none, right? So this is a flyweight. There's only one instance, which is very nice. This is actually a cancellation token that cannot be cancelled. So if I run this thing, then we should see that one is cancelled, but the second one still continues. So in case you're wondering, like, how expensive is that whole mechanism? Well, it really isn't. And the way to verify this is by looking at the source code. You can go to this website called source.dot.net, right? So all the source code is right there, and you can look for cancellation token. You can see that this is a struct, and it just has a reference to the source, and that's basically it, right? And the way that this works, like, how does this cancellation token know that it has been cancelled? Well, if you check here, for instance, is cancellation requested? All we're going to do is actually ask the source, and that's it. So both are actually quite simple. Now, there's one additional thing I should really do, and that is add this using statement right here, because this cancellation token source is in fact disposable. So you should clean it up. Okay, so in the previous example, you saw that I created my own cancellation token source. Now, this is not always necessary. There are many naturally occurring cancellation tokens spread out in .NET. Let me show you by creating this little web API right here. So if I go to my program here, there's already a method, just an example, and let's emulate some work, right? And I'm just going to do this like before. I'm going to await task.delay and wait, let's say 3 seconds to give me a little bit of time. Okay, so if I want to test this, you will see that I will just get an answer after about 3 seconds. Let me go to the browser right here, and then 1, 2, 3. There we go. We have our amazing weather. Now, what you can do in that time is you can actually cancel that request. So that means this browser is no longer interested in whatever output you have. So the way you deal with that is, if you go back here, you can just inject a cancellation token. And let me just put a breakpoint here. Let's start it again. Let's refresh this, cancel it, and then go here into Visual Studio. And what you will see now is that this cancellation token is indeed cancelled. It is set to true. So this happens automatically. You don't have to do anything for that. So the nice thing is you can just take this cancellation token, give it to the method that actually does the heavy lifting. And as we visit that page and then cancel, there you go. We should be able to exit that immediately. This task was cancelled not after 3 seconds, but immediately. So we can avoid doing all of that work. Another example would be this one. Let's add a class here. Let's say my queue reader, which would be some kind of background service that we have. There we go. And if I just implement this abstract class, you can see that right off the bat, we are faced with this cancellation token, which will inform us when we have to stop with this background service. Let's move to another example that I have prepared. Okay, so this is a little WPF application which represents an installer, right? And if you want to install an application, you have to go through various steps. You have to create and copy, extract a bunch of files. You have to write to the Windows registry. You have to create an uninstaller and, a whole bunch of these things. So this is a potentially long-running task, and we want to be able to cancel that. So how do we do just that? So let's go to the main window where I have two buttons. I have the start button and I have the cancel button. And you can see that I call this install method. Yes, it's a static method, don't blame me. So first of all, let's add a cancellation token source. I'll just call this CTS. There we go. I don't need that part. And then I can just pass CTS.token. Now, since we are using cancellation, I should definitely add a try catch block here. And then we have to catch the operation cancelled exception. Now, of course, we are going to need this cancellation token source here as well because we want to cancel it. So let me just create a field for that. Let's call it CTS. And actually, let's make it nullable because it might not always be assigned. And let's do this CTS is CTS. Okay, great. I do have to make sure that this gets disposed, but the using statement will take care of that. I just have to make sure that I don't do anything wrong. I shouldn't be able to talk to this thing when there is no cancellation token source, right? So I should probably set this to null once I am done. Maybe let's even move that into a finally block, right? Okay, great. So in here, if there's an operation running, we can cancel that. All right, so we pass along that token to the installer. So what we do here is we add that parameter, we jump straight into the method, and then we go to pass this token to the other methods that I have. And this is very natural, right? You just pass those tokens down in your application. It's kind of the opposite of the async keyword, right? Where you use this in a low level and it bubbles up. Well, this kind of bubbles down, let's say. So I need to ensure that this parameter exists in all of these methods. And then here we will just add an appropriate place, deal with that particular token. So I'm just going to do this, and I'm not going to actually cancel. Well, I'm not going to catch the exception here. This is also quite common. You don't have to catch it where you throw it. You can do that at a higher level. Typically on a higher level, you have more of an overview of what's going on in your application, while as you go down into your call stack, those little methods don't really have an understanding of the bigger picture, so they cannot do anything meaningful when you hit that cancel button. But I will do that here. So I will add my try catch here, operation cancelled exception. There we go. And then, yeah, I need to report that I have been cancelled. Okay, now I'm just going to throw this in here because if you're interested in long-running tasks, you probably want to use this as well. This is something not that many people apparently know about, but if you need to report progress in an application, you have this thing called iProgress. Yeah, this is not related to WPF at all. This is something I can use in any application, in any library. All it does is indicate that there is progress, and then here in this part, I can actually react to that. Now, this is a generic class, so I have to provide some kind of type, and I already made this install progress class, which just indicates the percentage that we're at and a description of what we are currently doing. So let me pause that here, and I'll call this progress, and I'll just pause this as well to all of these things as well. So usually the cancellation token would be the last parameter, but progress is another one of those, and I usually put it after the cancellation token. So let's add that everywhere. There we go. And then here we can take that progress and say report. And here we're going to create a new instance of that install progress thingy. So I need to know what we've done and a description, for example, creating files. And let's do the same thing for these other ones as well. So we are reporting that progress just fine, and maybe here we can also indicate progress dot report, and then here we can specify that we are in fact done with this thing, unless the operation got cancelled. So in that particular case, we could say, okay, progress dot report, and I'm going to just set the progress bar to 0 again, and then say operation was cancelled. By the way, dear Americans, why do you spell cancellation token with 2 L's and then cancelled with just 1? It doesn't make any sense to me, but okay, let's just go with it. Let's continue. So here in my main window, I'm already passing this cancellation token. Let's also create this progress thingy. So there is actually a concrete class that implements this, this interface. So let's call that install progress, and let's pass that along. Now, when you create one of these progress objects, you can pass along a delegate that tells it what to do when new progress is reported. So let's do that. Report progress, and I'll let it generate this method for me. And then we can just do okay, so we have this report progress method. Now, one additional cool side effect of this progress thingy is that it will also report this progress on the correct thread, right? So in WPF, I have to make sure that this is actually done on the correct thread. This object simply does that for me. Actually, come to think of it, I don't even need to catch any of that right here, since I'm completely dealing with that in this method right here. Let's see if that works. I'm going to run this. Let's hit start, creating files. And then after a little while, it should switch to write to registry and then creating an installer. And there you go, it completed. Let's try that again. This time I'm going to cancel that, and you can see that this operation was indeed cancelled. Let's use this example right here, and let's talk about a whole bunch of best practices and potential pitfalls. Okay, so best practice number 1. Prefer throwing the exception instead of just returning early. As I mentioned before, instead of throwing this cancellation request, what you could do as well is just if token dot is cancellation requested, and then you can just return. This is typically what you're not going to do. Why not? Simply because that's not what people expect. People expect this exception to be thrown. That's just the way things work. If you take a look at all of the built-in methods in .NET that take cancellation tokens, they will throw that exception. If you take a look at most third-party libraries, they will throw that exception. So this is a bit odd, especially because if you just return, there's actually no way of telling, like, did it complete successfully or was it an early return? So you would have to indicate that in a different way. Now, to show you why that is important, that to fulfill this expectancy, well, remember that these things are tasks, right? So let's say that I keep track of that task. Let's say the create files task, and let's just make it null for the time being, and let's assign it to this one, and then we can just await create files task right here. Now I did this to have a reference in my catch block here, and then in here my task, the create field, I can actually ask, right, was this particular task cancelled? If you didn't throw the exception, this will not be set to true. If you did throw the exception, it will be set to true. So it is just the way that tasks work in .NET. All right, so let's say that you write code like this, where you're going to write something like this, continue with, right? So once this is done, I want to continue with another task, right? Now you only want to do that in certain situations. So we could say task continuation option only on cancelled. Yeah? And once again, this thing will only work properly if you actually throw the exception. So we expect this exception. We expect it to work in a certain way. So I'm not going to tell you to never return early from a method. If you own both the calling side and the called side, you might actually do that, right? Sometimes it makes sense. In my current job, we actually have a bunch of code that tries many different things, and we're quite happy if one of those things actually works. And we have a ton of timeouts in there. Timeouts are caused by, well, these cancellation tokens. So we have a lot of these operation cancel exceptions. Now, exceptions could be slow from time to time as well. So we try to avoid that. And since cancellations are not exceptional, well, we don't throw the exception. We just return early. We indicate that nothing went wrong. We simply didn't find what we were looking for, and then we can continue. If you go that route, if you decide, okay, I'm just going to return early, please document that, right? Write it down somewhere, and you can just do that right here. You can use summary, you can use remarks. You can even put that in here, like, okay, I pass along this token, but it works like this. Now, personally, I would at least put it in the summary or the remarks, because not everybody is going to take a look at this thing right here. But if you don't throw the exception, please document your behavior. And actually, if you do throw the exception, well, you can document that as well. I return this particular exception. Number 2, don't forget to dispose your cancellation token. The safest way to do that is by using this, well, using statement. You could also dispose it once I close this main window, but I like doing this as soon as possible. Now, you might be wondering, what's there to dispose? Well, actually, if I go to the source code, what you see here in this dispose method is that internally I might use a timer. And remember that cancel after thingy? Yeah, well, that's because of this. And you also have this, the manual reset events. Now, both of these are optional. They could be used, they could not be. But just make it a good practice to always dispose it, because this indeed uses unmanaged code and needs to be disposed of. All right, number 3 is to just pass these cancellation tokens everywhere. Even if you're currently not really all that concerned with cancellation, it's far easier to just add it right now than to add it somewhere in the future, right? If you're doing an HTTP call, if you do DB context save async, where you could pass a cancellation token, yeah, maybe you should provide that method with a cancellation token as well. It's quite natural for these things to flow through your entire application. So just do that. But hold on, maybe you don't actually want this token because you want to be able to deal with the cancellation right here, and you don't want to have to deal with it here. Well, one thing that you can do then is just pass this thing, cancellation token.none, and make it very explicit that you don't want to pass the current cancellation token. So I'm going to deal with number 4 and 5 at the same time. So first of all, check your cancellation token regularly. And second of all, handle cancellation gracefully. Now, if you've watched the video so far, that should make total sense. But it doesn't always happen, right? And that's because most of the time, passing cancellation tokens is quite mindless, right? You just have these methods. You pass the token, then you call this method, and then you pass that token again, and then again and again and again until you hit one of these, right? Like a built-in method from dotnet that will then has to deal with this particular token, and this makes sense. Other examples are like dbcontext.save changes async, then you would pass a token in there as well, or like an HTTP client, something like that. So quite typically, you just pass along your token until it hits that point, and there it will throw the exception and so on. And for the vast majority of your work, this will be sufficient. That's the thing that you want to avoid waiting for. Now, the problem with that is you just stop thinking about cancellation and expect that it happens magically, but that's not the case. You have to think about what really happens if I cancel this particular thing. Because you might say, okay, DB context, don't save the changes, but maybe you've modified these objects and you have to undo those things, or you've already cached some of these changes. So you might need to clean things up, and that simply doesn't happen. So most of the time, you're just fine with just passing these cancellation tokens until you hit one of these methods. But that's not always the case, and people kind of forget to reason about this. Also, some people kind of consider cancellation tokens to be valid for asynchronous code, but it's just as valid for synchronous code. Synchronous code can take some time, and sometimes by avoiding doing a bunch of work, you can avoid having to do a lot of cleanup. I actually try to do that quite a lot just at the very beginning of your method. Just immediately check, right, before you start doing anything. It's so much easier to clean this up. All right, number 6, avoid trying to catch this operation cancelled exception unnecessarily or unintentionally. And what do I mean with that? Well, I've already mentioned that in these methods, if you're not doing the cleanup here, you don't have to catch it. Your cancellation can be very deep in the call stack of your code, and it can bubble up to a place where you actually know what's going on and have to deal with the situation. So don't think like you're obliged to deal with that exception on every single level. Second of all, sometimes the following thing happens, where I add this try block and I add this thing right here, catch, and then I do something. But I'm trying to deal with all sorts of exceptions, right? A lot of things could happen. I'm actually not that interested in what really happens. I'm just going to log it and then continue and so on. But this catch block catches every exception, which includes our operation cancelled exception. Actually, we don't want to handle that here. We want that to bubble up so we can deal with that on a higher level. So what I should add here is check the type when X is not an operation cancelled exception, and then just continue. This is something that is very easily overlooked. Yeah, people just deal with the exception and forget about the fact that a cancellation token could be thrown. I actually write this a lot in my code, and it's so easy to overlook. Number 7 is don't assume that cancellation is immediate. First of all, it might actually be too late already. If I think about my installer, at a certain point, it doesn't make sense to try to roll back anymore. I'll just finish the installation and you just have to uninstall after that. Having a cancellation token means you can do something with it. You don't necessarily have to. It might not respond to your cancellation token at all, and if it does, it might not do it immediately. Now, I have encountered a few libraries in .NET itself, but also third-party libraries that actually do check your cancellation token, but not until a later stage. If you're in doubt or you detect this kind of behavior, right? So you call this method, you don't know exactly when or how this token is checked. Just check it yourself right before you call that method. Why not? Right, number 8 has to do with CancellationToken.none and optional parameters. Let me show you. Let me create an overload here where I don't have this progress thingy. And I actually want to make this optional. So by default, I will just specify CancellationToken.none. Now this doesn't work, right? And if I hover this, you can see why it must be a compile time constant, which this thing is not. So what do you see people do? And I really hate this. They just do the following, right? Oh, let's just make it nullable. I'll pass along null. And then right here, they're going to say, okay, token, if you are null, then I'm going to put CancellationToken.none in here and then just continue. That works, but it's stupid. I don't like the fact that this is now nullable, and yes, I know Visual Studio is smart enough to figure out that this token at this particular point is no longer nullable. But still, it bothers me because the solution is so easy. You just type is default, and that's it. Don't make it nullable, just type is default. And if you don't pass a cancellation token, it will be CancellationToken.none. How do I know that default is exactly the same as CancellationToken.none? Well, just check the source code. If I go back here to my cancellation token, you can literally see that here. CancellationToken.none is the default value for cancellation token. So please, just use default if you want to make this optional. Number 9 has to do with task.run and how to use a cancellation token there. A lot of people get confused about this, so let me show you what I mean. I do task.run and I pass along an inline delegate right here. And then here, you can actually pass along a cancellation token. So yay, great, let's do that. Now what some people do is that they expect that this task will be cancelled immediately when the token asks so. That's not the case. All this token does is allow this task to be scheduled or not. So once this task has been scheduled, once it has started its execution, this one is no longer looked at. And that's why sometimes you have to take the token again. You can just use a closure, see, check if the cancellation token is requested, and so on. So you still have to check it in the method itself. You cannot just rely on this. The same thing is applicable to the following. If I have parallel dot for each or any of these other methods, let me just pass along a collection here. We can pass along this method, right? That tells it what to do with each one of those elements. Now what you can do as well is you can pass along what we call these parallel options, where you can specify a cancellation token. So I pass that right here, and that should work. What this cancellation token does is whenever it needs to schedule the next iteration, it will do that unless the cancellation has been requested. But it doesn't do anything in the action itself. It doesn't stop the action halfway. Hopefully that is very clear. So this is a typical pitfall, and it kind of explains why sometimes you see these tokens appear multiple times. Number 10, don't use task cancelled exception. You have this thing called task cancelled exception. Just ignore this. It's really not worth the effort. If you take a look at this, this exception is an operation cancelled exception with the additional task, right? So in here somewhere, there's a property that returns you the task that has been cancelled. If you really need access to that task, yes, you can use this. And then you might not have to do something like this to see, which one of these tasks was actually the cancel task. But most of the time, you don't need that information. And then people forget about the synchronous part, right? If you check the cancellation token right here in the beginning, or here rather, then this will not catch that, right? So be careful if you use this. Only use it when you thought is true. Just use operation cancel exception as your default. All right, and then the last two best practices are using link tokens, which we'll get into in just a second, and then also registering for cancellation events when appropriate. So let's talk about those. Okay, so let's talk about, well, actually two things. Let's talk about timeouts and how to link tokens and why these two are related. So imagine I have this class right here, which is going to do some kind of network stuff, right? And I'm going to use the UDP client to listen to incoming messages on the network. So let's say that I listen to this particular port and I just say UDP client dot receive async. Let's await this method. Now the problem here is that this method can block for all of eternity. So we probably want to provide some kind of timeout. And maybe I have a property of preferably type time span, and let's just call this timeout. Let's maybe give it a default value. Okay, so I'm going to wait for a maximum of 3 seconds. How do I pass along this timeout here? Well, there is no overload that takes a timeout. There is one though that takes a cancellation token. Now you might say, whoa, wait, there is a timeout. Yeah, if you go to the UDP client and you go to the underlying socket, there are actually timeout, right? You have the receive and the send timeout. However, these methods only work for synchronous operations, right? They don't work for this asynchronous operation. And that is actually a quite common theme in .NET, right? So for synchronous operations, they will provide an overload or some mechanism that takes a timeout. But if you have an asynchronous method, you have to deal with it using cancellation tokens. First of all, I'm going to need a cancellation token source again. Let's call this timeout source, just to be very clear. And then the cancellation token itself, just once again, I'm really spelling it out here. And let's pass that one here. So as we've seen before, what you can do is right before this method, we can say timeout source dot cancel after, and then we can pass this timeout, so time span or milliseconds. Actually, you can do this even easier. You can actually just pass it along right here. So I can just specify my timeout here. Now, I do prefer it this way because maybe you have to do some setup before you actually start with this. You can move this closer, but let me just do it like this. This should work, and after about 3 seconds, it would throw the exception. Now here's a problem with all of this. Let's say that this one also takes a cancellation token. So maybe I have a button somewhere that I can press to cancel the whole operation. Which one do I pass? Right? This one or that one? And this is where these linked cancellation tokens come in. So in addition to what we already had, I'm going to use another cancellation token source. And here I'm going to use cancellation token source dot create a linked token source. So I can just pass a collection of cancellation tokens. And yeah, don't worry about this read-only span. It's a new feature of the params keyword. You can just pass along any collection here. So not just one or two tokens, you can pass as many tokens as you like. So let's do that. Let's pass along the original cancellation token and let's pass the timeout cancellation token that we've just created. And then we have this linked source, let's call it, and let's pass that. That's the one which is going to throw the exception. But what if I want to respond differently when it was a timeout versus when it was cancelled by the exterior mechanism? Let's add our try catch, and you can do it here or in any of the calling sites. Let's listen for this operation cancelled exception. So the first thing I would like to point out is that you do get your cancellation token on the exception. So you know which cancellation token actually caused the issue. Now, that's useful if you have two independent things going on simultaneously with both their own cancellation token. But in this case, the cancellation token in the exception will always be the linked cancellation token. So I actually don't know whether it was caused by this timeout or this external cancellation token. So that's not going to really help me here. What I can use instead is, and I like to use this approach, when, and oh yes, you can already see it. There we go. When timeout cancellation token is cancellation requested. So I can check it here on this token. I could also just check it on the source if you like. And then here, maybe I want to throw a new timeout exception. And then the other one, this one, I'm simply not going to catch, and I'll just have to deal with it wherever I call this listen method. And that's the beauty of these linked cancellation tokens. We actually have in total 3 cancellation tokens now, which is a lot. Can we do with a little bit less? Well, in this particular case, yes. Because what we could do is actually kind of use this linked cancellation token as a double for our timeout cancellation token. So let me just get rid of this one. And I'm just going to pass this token to this source. And then I get this new token, which is also going to trigger when the original token got cancelled. And in here, we're just going to use the linked source. And then right here, we'll just do the opposite. If the cancellation token, the external one, if it wasn't that one, I know it has to be caused by the timeout. Now, this code is less readable, but you create fewer objects, so the choice is yours. Actually, you can turn this into a nice extension method. Now, you can do that, but there's already an open source project that does that, named Poly, which has been recently redeveloped and incorporated in dotnet itself. And let me just show you that for a second. Okay, so let me just add this package right here called, this one, Microsoft.extensions.resilience, which is basically Poly. And what you have here is you can use the following things. You can create what we call a resilience pipeline. And there you go. You can see that it's still Poly, right? So let's call that pipeline, and let's use a resilience pipeline builder, and let's add. There are a ton of cool things that you can do right here, but let's add this timeout right here. So you can see that it added my timeout right here, and then it builds this particular timeline. Maybe I'll just duplicate this for a second. There we go, so we can compare. All right, and then here in my pipeline, I can in fact use that same thing. So let me create my UDP client, and then here I can use execute async, and then say I want to use that UDP client. Now, you see that I actually receive a cancellation token, and then I can pass that cancellation token to this receive async method, right? Oh, brilliant. Let's do this. So this is exactly what you shouldn't do. Copilot tried to help me here. Yeah, this is exactly what we shouldn't do, because right now, this will only be cancelled if the cancellation token from the exterior world will be triggered. So instead, what I need to do is I need to use the cancellation token that was given to me from this pipeline, and then I can pass the cancellation token right here. So behind the scenes, this will do exactly what we did here. It will create this linked token. So this token will respond both to this cancellation token and the timeout. And if it is caused by the timeout, it will throw a timeout rejected exception, and otherwise it will just do the operation cancelled exception. So really cool library. I can even simplify this a little bit, but I think it's a bit more readable the way it was. So I'm just going to keep it at that. All right, last one. Let's talk a bit about registering for the cancellation event. So I have another example right here. What's going on here? I read a certain file, and then I, do something with it, like go through it line by line, and then spend a few seconds processing that line, and so on. Right. So this is something we can cancel. And just as we learned before, I can do this. At an appropriate place, I can check the cancellation token. If it has been requested, I throw the exception. However, this thing might take a while. And you can see that it takes a second for each line to process. So that might be a little bit slow. Also, let's say that you do other work, you have a background task, and it checks something every 24 hours. Just checking that in the beginning of the loop might be way too slow, right? Sometimes you want to respond immediately. So let me add the following piece of code here. So what happens here? Well, this token has a register method. You can do this both on the token or on the source. It's the same thing. And then you can register this this delegator. So this is the important one. I want to release that file stream as soon as possible. And then here I can still continue. I can still continue doing my processing. I will not stop halfway this particular task right here. And then on the next iteration, I can then say, okay, let's call it a day. Let's stop. So this will not throw the exception, just to be clear. It's just a side effect of that immediately happens when the token has been cancelled. A couple of things about this. First of all, why is this not just a regular event? Why is it not like, okay, token dot cancellation something something plus equals some kind of event handler? Well, that's because there's some additional work ongoing here. Imagine that this cancellation token has already been cancelled before I do this registration. Well, if it were just an event, I would be too late to respond to that event. But that's not what this register method does. If I go to the definition, we have this registration. And what it does is it registers a callback. But if cancellation has already occurred, the callback will have been run by the time this method returns. So if it was already cancelled, it will ensure that this is in fact called. Now, I would still rely on this using statement right here, just in case it throws an exception or anything like that. But basically, we're guaranteed that this thing will be called sooner or later. Second thing you need to know about this registration is remember the cancel method. So let's say that in some kind of thread or whatever, I call the cancel method. This cancel method will only return once all of these side effects are done, right? So if you have something that might actually take a while, this might block your current thread. And that's why you have the cancel async as well. So you can just await that one. It will not block your current thread, but it will only return after all of these methods are done. Do you have to call this by default? I would say no. I think the normal cancel method is still the way to go. Usually there will not be that many side effects and they should be quite short. Remember that calling this asynchronous method does have an overhead of creating a task and scheduling that, and requires grabbing a thread from your thread pool and so on. So usually I don't think it's worth the effort unless you know about certain registrations that, might take a little bit longer. Now, my go-to example for this in the past would be using timers, but these days you have this periodic timer, and then you can use timer.wait and so on. But this method now takes a cancellation token. So and it will respond to that immediately. So if you just use periodic timers, you don't need that registration per se. But if you use the classical timers, the one from system.threading or the one from system.timers, then this one might be useful. And I think we're done. Yeah, this is everything you needed to know about cancellation tokens. So if you stuck with me until the end of the video, thank you very much. If you have any additional questions, you can put them somewhere around here, and I will do my best effort to answer them. Also consider liking and subscribing and all of that stuff, and I'll see you the next time.